Step 4 is where we actually calculate the test statistic. This is where we have to use the formulas that are going to be provided on the exam. So first thing we're going to look at is the t-statistic formula. And that is going to be t equals sample mean of first sample minus sample mean of the second minus the hypothesized difference, mu1 minus mu2. These two both have tildes. Divided by square root of the population, sorry, the pooled variance times 1 over n1 plus 1 over n2. Okay. Right now we need to figure out where these values for this problem. I'm going to now just plug in these values. We're told x bar 1, the sample mean from the first sample, is 10.01. Subtract from that the sample mean of the second sample, 9.12. Subtract from that the hypothesized difference. And we said earlier, based on our null, that the hypothesized difference is 0. So I'll write 0 there. Divide that by, now the square root. I'm going to plug in the value of I'm plugging the values for the pooled variance here. That's going to leave me with, in the numerator, sample size of the first sample minus 1 times the sample variance. We're told the sample standard deviation is 4.43. Since we need the sample variance, we're going to square that. Then we're going to add to that the second sample size minus 1. Second sample size is also 120. Multiply that by the sample variance, and we're told the sample standard deviation for that is 4.45. 4.45. And we're going to square that. And that's all divided by the two sample sizes, 120 plus 120, two of them summed together, minus 2. Okay, so this whole term here is the pooled variance. And I have to then multiply that by 1 over the first sample size, 120, plus 1 over the second sample size, which is also 120. Again, a pretty complicated formula there. So when you calculate this, what you want to do is each step again round it to the 4th decimal place. So it'll be 119 times 4.43 squared. Find that value, do the second term, do that division, then multiply it by that value. Take the square root of all that, and then the last step will be take that numerator, divide that by the result. And the final result after all those calculations should be roughly 1.55. Okay, so that's the value of our test statistic. Okay. With that value, we then compare it to the rejection region. We said our rejection region, which I happen to erase, was when the test statistic is an absolute value greater than 1.96. So our test statistic does not fall in the rejection region. Therefore, we fail to reject the null hypothesis. So we fail to reject the null. Okay, so that completes step 4 there of calculating the test statistic and comparing it to a rejection region. Again, the rejection region, which I happened to erase, was when the test statistic was greater in absolute value than 1.55, or sorry, than 1.96. And we know that 1.55 is not greater in absolute value than 1.96. Okay. And so our next step that we'll look at is to calculate the p-value. This is now step 5. And again, the two things we need for the p-value are, again, the type of test and the value of the test statistic. Okay, again, picture can help here. Looking at a t-distribution, centered at 0. And we see here the value of the test statistic we found earlier was 1.55. So I'm going to plug that in right here. I know that takes care of this value, or the test statistic. Now I need to apply the type of test. Well, I have a two-tailed test. So that means my p-value includes this area to the right plus the area to the left of negative 1.55. Again, this is due to the fact that we have a two-tailed test here. Okay. So I'll write this in an equation. So our p-value then is going to be the probability that a t-statistic with an infinite degrees of freedom, we found that earlier, is less than negative 1.55 plus probability that a t-statistic with infinite degrees of freedom is greater than positive 1.55. Okay. Well, our t-table, if you remember, is a right-tailed table again, so we can't find that probability, this first one, directly from the table, but because it's symmetric, we know these two are equal, so I can rewrite this as 2 times the probability that t with infinite degrees of freedom is greater than 1.55. That's going to be our p-value. Okay. Well, let's find that probability. We're going to go in our infinite row here. We see 1.5 falls between these two values. And so we know from our table then that the probability that t with infinite degrees of freedom is greater than 1.55 is somewhere between, we see the lower value there is 0.05, so that probability is greater than 0.05. Go up to the top of this first column, we see the upper bound of the probability is 0.10. Okay, so we know that probability is between those two values, but that's not the p-value. We have to multiply these two endpoints to find the p-value, because remember the p-value is 2 times that probability. And so 2 times 0.05 is 0.10. So we know then that p-value is going to be greater than 0.10, but less than 2 times 0.10, which is 0.20. So that then concludes problem number 13.12. The conclusion is that there's not enough evidence, since that p-value is greater than 0.10, to conclude that there is a reduction of O brand versus the other grain series, or there's any difference, I should say.